Stan Gibilisco here to discuss the basics of wind power and in particular how wind turbines get electricity from the wind. And what you're looking at right here is a very sunny, very windy place about 7 miles outside of Cody, Wyoming. 2 acres of land with a little trailer on it that I acquired about a year ago called the Long Wave Ranch, a very modest piece of property, but the wind almost always blows here, as you probably have heard about Wyoming, and it's very sunny in Cody. Actually, you get more sunny days in Cody, Wyoming, I believe, than you do in Tampa, Florida, for example, although the intensity of the sun is a little less. But for solar and wind alternative energy options, that was part of the consideration when I bought this place. I might move there someday and get a little greener, maybe write a book about that too, but you got to make it affordable. Here's, though, the basic principle of how a wind turbine works. Now, what you're looking at here is a diagram from my book, Alternative Energy Demystified, 2nd edition, a link to which I will provide in the description of this video. This is figure 11-6, actually, on page 219 of that book. It shows a large wind turbine connected into a transmission line, and here's basically the way that it works. You've seen these things most likely. These blades here can be upwards of 50, 70, even maybe 100 feet in radius or length. So the turning radius of a thing like this is gigantic. It doesn't go around real fast, maybe 20 revolutions per minute. So you need a gearbox, but it has a lot of mechanical torque to create alternating current. The electric generator is powered by means of that torque and generates electricity from that turning force. Then you have a transformer of some kind or another, and then it links into the transmission line, which goes, well, to wherever the users may be, or to a power station that can combine the wind power with other sources of electricity, because obviously the wind does not always blow. This is a functional diagram of an electric generator. You have a coil which rotates inside of a pair of powerful magnets. They may be permanent magnets, they may be electromagnets. But this rotatable shaft is what goes to, that's this right here between the gearbox and the generator. Rotatable shaft, gearbox, right here, and you get your AC output from the coil. So that's how this whole business works. The armature coil is rotated by the torque from the blades on the wind turbine, and then this actually shows the wires, not the shaft itself. The shaft might go up in the other direction here, but the idea is that when you rotate a coil like this, in this orientation between the poles of a powerful magnetic field, you get an alternating electric current in that wire, because any wire that moves in a magnetic field will develop a current in itself. And that's the principle by which pretty much all electric generators work, even right down to the little portable generator that you may have for the purpose of backing up your electricity when the power fails during a winter storm or something. What we're looking at here now is a smaller wind turbine that you might use, well, that I might use at the Long Wave Ranch. This is a standalone circuit right here. The generator, the wind turbine, turns a lot faster than the 20 revolutions per minute of a large generator. In fact, the speed of a generator like this will vary. So you need some kind of a regulating circuit, a rectifier, and a regulating circuit to produce direct current from the alternating current that comes out of this wind turbine. That charges batteries. This charging circuit has a charge regulator in it and everything to make sure that the batteries don't get overcharged. And then these batteries, which may be large lead acid cells, marine batteries, or possibly even more advanced technologies. They're working on those technologies, by the way, and improving them all the time so that you can get more and more and more electricity stored in a smaller and lighter package. They're working on that kind of thing. And they're doing pretty good with it too. If you get a reasonable battery bank and take care of it, then you have a power inverter, and that converts this DC back to regulated 60 hertz, 117 volts AC. Now in the United States, it's nominally 117 volts at 60 hertz. In some other countries, maybe about twice the voltage, and oftentimes only 50 hertz. But this inverter can produce a constant voltage regardless of the amount of load that appears at this outlet here. If you didn't have that, if you didn't have this inverter and battery bank and just tried to run the generator straight into your wall outlets, you'd get unregulated, wildly fluctuating voltages, and you couldn't really make any use out of it. So in a sense, you're kind of doing and then undoing. You have alternating current coming in here, which is changed to direct current here, and then back again to alternating current, except the alternating current that comes out of this inverter is a lot cleaner, smoother, and more constant than the alternating current that comes out of this wind turbine. But of course, this circuit can produce power only when the wind blows, and that's why you need to have a large capacity battery bank, so when the wind doesn't blow, you can still get power for a while. Now, in a place like the Long Wave Ranch in Cody, Wyoming, windless periods are rather few and far between. And, as I said before, you can also add solar panels to the mix and produce what they call a hybrid alternative electric system. And that's what I would like to do, and I would like to make it a standalone system that powers only the essential items in my little trailer there on the 2.2 acres of desert northeast of Cody, Wyoming. Stan Gibilisco signing off for now. Until next time, so long.